Hey math leaders, welcome back to our video channel or whatever you want to call it. Thanks so much. You guys did a great job in week one of doing your problems. Many of you got all your problems right. Many of you did the bonus challenge, which was the Nerdle, and many of you got that in 3 tries or less, so you got your extra bonus points. Those of you that weren't on it in week one, that's okay. Let's go after it in week 2 and let's get all those problems done and take your time. Remember, you got the whole week to do the 15 problems, so do a few one day and then a few another day and get them right. And anyway, here are the answers. I'm going to post them also on the message board as well. But if you want to just take a look, here are the answers for the week 1 problems. Okay, I just happen to have them sitting up here. And I'm going to really quickly go through all of them. Okay, I'm going to go super fast and I'm going to talk fast. The reason I'm doing that is because I'm on video. And so you are more than welcome. When I get to a problem, I'm going to start going through them. And if you're not interested in seeing me do question number 4, just fast forward past that. You're not interested in seeing me do question number 7, fast forward that. You don't want to see me do any of them, don't watch the video, it's fine. But like what I'm saying, I'm going to go super fast so the video doesn't take too long for those of you that are going to sit and try to figure out what you may have done, or you might want a trick for how to do things faster and so forth and so on. Okay, so I'm going to take this board down and switch with this board. And there's going to be a lot of board switching. And you know what? Before I begin, I should also do the joke of the week. Sometimes I'll do a joke on the midweek hints video. Sometimes I'll do a joke at the end. Since we're kind of in the beginning of this thing, you guys should get a joke. For those of you that did this last year, look, I apologize. There's only so many math jokes out there. And so some of them you may have heard before, but here goes one. The oldest math joke ever that everyone always tells is, why is 6 afraid of 7? Because 7, 8, 9, right? That's like the silliest, oldest math joke there is. But the question is, if 7, 8, 9, why did 7 eat 9? Because his doctor told him to get 3 square meals a day. It's an old expression. Eat 3 square meals a day. All right? 3 squared is 9, so you're eating 9. All right. Did you really need me to explain that joke? All right, I'm going to go through the problems really, really quick. Number 1 was Bob can paint a house in 8 hours by himself. Joe can paint a house in 6 hours by himself. Fred can paint a house in 3 hours by himself. How many minutes will it take all 3 of them? Now look, I think I gave a hint on this one, but your little formula, this is number 1, A times B over A plus B. But you can't do it with 3 people. You can't do like A times B times C over A plus B plus C. So what you do is I took 2 people at a time. Joe could do one in 6 hours and Fred could do one in 3 hours. So I did 6 times 3 over 6 plus 3, which was 18 over 9, which was 2. And that was Joe and Fred. So call that one person, Joe Fred. Joe Fred is 2. And then Bob could do it in 8. So it's like Bob with Joe Fred. Okay, so it's 8 times 2 over 8 plus 2, which is 16 over 10, which is 1 over, 16 over 10 is 1.6, or 1 6/10. If you think about it, it was asking how many minutes. So 1 hour is 60 minutes. 6/10 of a minute, 1/10 of a minute, sorry, not minute, of an hour, 1/10 of an hour is 6 minutes, so 6/10 of an hour is 36 minutes. Yeah, I don't redo these videos when I fumble flub. So it would be 96 minutes. So that was number 1. All right, moving on, going fast. Now for number 2, and like I said, you can fast forward the parts where, like I'm erasing the board. It says Ruby really likes the number 90. She wants to have exactly 90 average on her 5 math tests. She's taken 4 so far, and her scores are 80, 84, that's terrible, 91, 87, and 96. 84 is not a terrible score, just the way I wrote it is terrible. And 96. Okay, boy, that's really bad writing. Okay, so anyway, she wants to average 90. There's a formula you could solve. You could put in a variable like x, and say like this plus this plus this plus this plus x divided by 5. But it's much easier to just say, look, she wants to average 90. The easiest way to average 90 is to get all 90s. So here she's 6 points down from her goal. Here she's 1 point up from her goal. Here she's 3 points down from her goal. Here she's 6 points up from her goal. These two are going to cancel out, all right? And so she is now 1 point up and 3 points down, so she's 2 points down from her goal, so she needs to make that back up. And she wants 90 average, so she needs a 92 on her last test, okay? Number 3 is a smiley face operation. Ooh, and I forgot to change this. That's okay. I'm going to do it this time. Number 3 is the smiley face operation, and that is a smiley b equals a squared plus 2ab squared. A smiley b equals a squared plus 2ab squared. Okay? And so it wants 3 smiley 4. All right, so you just square 3. 3 squared is 9, okay, because that's the a, like 3 is the a and b is the 4, plus 2 times 3 times b squared. Remember, you square before you times, order of operations, so you do 4 squared, which is 16, okay, 4 times 4 is 16, and then remember you multiply before you add. So you got 16 times 3 is 48, times 2 is 96, plus 9 is 105. Okay, 105. The next one of my favorites, I asked this question or one similar on just about every test that I give, like as a bonus problem. There's a famous movie from back in the 80s called Stand and Deliver, where they do, it's about a math class, and during the movie they actually do a math problem similar to this one. So it says Juan has 5 times as many dollars as Pedro. Sally has this is number 4. Sally has $6 less than Pedro. And if the total number of dollars between the 3 people is 57, how many does Sally have? So here's the fastest way to do it. Juan has 5 times as many as Pedro. Juan is 5 times whatever Pedro is. So if Pedro has $10, Juan has $50, okay? Sally is $6 less than Pedro. Sally is whatever Pedro is minus 6. And guess what? Pedro is just Pedro. Now, again, you could make a chart where you list Juan, Sally, Pedro, and you could just sort of guess and check, and that would work. Here's a quick algebraic way of doing it. Okay, so we know that Juan plus Sally plus Pedro, it said the total number of dollars between them is 57. Okay, so then we just replace Juan with 5p because they're the same. We replace Sally with p minus 6, and Pedro's still just Pedro. And that is 5 p's and 1 p minus 6 plus 1 p is 57. So I got 5 p's and 1 p and 1 p. That's 7 p's minus 6 is 57. So I get 7 p's is 63, right? Because I add 6 to both sides. And then I divide by 7, and p equals 9. Okay, cool. That was number 4. Number 5 was, number 5 was the one where Ben is now certain age. Let me look at it really quick. Yeah, I don't know. Maybe next time I won't do all the problems, but I'm going to do it this time. I'm going to go through all of it. Ben is 14 years older than Andrew. In 5 years, Ben will be twice as old as Andrew. So Ben is whatever Andrew is plus 14. And in 5 years, so Ben plus 5 will be twice what Andrew will be in 5 years. All right? And then again, this is just kind of like the last problem. I'm just going to substitute, since b is equal to a plus 14. And by the way, this is another easy one to just guess and check. All right? And just play around with the numbers. But if you want to do it algebraically, I replace b with a plus 14. You distribute here, you get 2a plus 10. I don't know how good you guys are at solving equations. If there's an a, it's 1a. So it's a plus 19 equals 2a plus 10. Now in my class, we like to do this thing called flinging, where you can move terms from one side to the other. Some people don't like it, but I love it. So I'm going to move 1a over here and subtract it. So 2a minus 1a is 1a. I'm going to move 10 over here and subtract it. 19 minus 10 is 9. So Andrew is 9, but be careful. It asks how old Ben is now. This is now. This is 5 years from now. So Ben is 9 plus 14. Ben was 23. Okay, we're moving fast. I'm going to have to go faster. All right. Number 6 was Austin has 4 friends. Al, Bob, Chris, and Dave. He has 3 tickets to go to the FC Cincinnati game. How many different combinations of friends could he take? Okay. Now, again, if you go on the message board, there's a sheet that I put out. It's Mr. T's Math Must Knows. There's special formulas using factorials and combinations and permutations and things like that. Look it up. It's really cool. There's some easy way to do this, but here's how I like to do it. Austin has 4 friends. He has 3 extra tickets. So here is ticket number 1, ticket number 2, ticket number 3. Okay. How many different people could he give ticket number 1 to? 4 people, because he's got 4 friends. How many people could he give ticket number 2? 3 people. All right, and then we're assuming he's not going to give like 2 tickets to 1 person. How many people could he give ticket number 2 to? 2 people. Okay? So, he could give, in how many different ways could he give out the tickets? There's 24 ways. However, out of all those ways, some of them are double ups. What I mean is, like, if he gives the first one to Al and the next one to Bob and the next one to Chris, he's still going with Al, Bob, and Chris. If he gives the first one to Bob, the second one to Al, and the third one to Chris, it's the same thing. So what we have to do is find a way, how many ways of these are like double ups or triple ups, where we're just rewriting the same group of people over and over again. And there's a way to do that. If there's 3 people, 3 factorial, which means 3 times 2 times 1. Hopefully you'll get used to factorials. Like, 8 factorial means 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. It's just what it means. A factorial is the number of ways you can rearrange that many things. So you can rearrange 3 people in 6 ways. So we divide by the number of ways that you can rearrange them, because again, these are the same grouping. So 24 divided by 6 is 4. Okay? All right. Now, for example, I always do this in class. if it were like a batting order or something like that, where the order mattered, not like what it actually matters what order you give the tickets, then there'd be 24 ways. Okay, but it's ways you can go to the concert with 3 friends. It's the same 3 friends, so we got to eliminate all those. All right, number 7 is twin primes. Twin primes consist of 2 consecutive odd numbers that are both prime. For example, 5 and 7. How many pairs of twin primes are between 9 and 99? And be careful to put down the number of pairs. All right, so really fast, that one is really just listing them out. It's really just kind of grinding through your odd numbers, and between 9 and 99. So you say like, and it's actually between 9 and 99, so 9 is not one of them. But anyway, you say like, all right, what about 9 and 11? Is that a twin prime? No, because 9's not prime. 11, okay. 11 and 13, yes. Oops. So this is number 7. 11 and 13, yes. Okay. 13 and 15, no, 15's not prime. 15 and 17, no, 15's not prime. 17 and 19, yes, 17 and 19. Okay, and if you just keep going, they are 29, 31, 41 and 43, 59 and 61, and 71 and 73. You know, like all the ones in the 80s and stuff, like they're not prime, like 80, like 87, 89, 87 is not prime. Okay, 81, 83, 81's not prime. Right, so that's it. 1, 2, 3, 4, 5, 6. That was number 7. Number 8 is, what is the sum of the first 100 even positive integers? There's a trick to these, and I think I gave this as a hint, but 2 plus 4 plus 6, 100 of them. So one way, you got to figure out, this is number 8, by the way, all right? You got to figure out what's the 100th even positive integer. Okay, well, the first one is 2 times 1, the second one is 2 times 2, the third one is 2 times 3, so the 100th one is 2 times 100. So 200 is the last one, the one before that is 198, and so on and so on and so on. The quickest way, there is a formula, but again, the quickest way, if you pair these up, 2 and 200, 202, 4 and 198, 202, 6 and 196, 202. Okay, so if you pair them carefully, every pair is worth 202. Well, if there's 100 numbers, how many pairs are there? There are 50 pairs. So all you gotta do is 202 times 50, all right, which is 10,100, okay? And remember, all of you guys, the way our program is set up, when you input your answers, we want to put them in very carefully. We don't want to put units. We don't want to put commas, things like that, because when we set it up, we want your answer to match our answer perfectly, or it won't read it correctly. Okay, we're working on like finding ways to make adjustments, like if you did put a comma and stuff like that. But for now, just follow the directions. All right, number 9. We are trying to go super fast. Number 9 is, I'm going to have to get the dog in here in a minute to help us with these problems. How many positive integer factors does 540 have? Now again, there's a really cool trick. I never learned this in school. I learned this coaching math counts. But what you do is you take the number 540, you prime factorize it, and so we're just going to go like 270 times 2, and I notice like that's 3 times 90, and that's 10 times 9, and that's 5 times 2, and that's 3 times 3. Okay, so we're there. We got a 5, just one of them, 5 to the first power. We got 2 to the second power, and we have 3 to the third power, okay? And it's just this really cool math counts type of trick that I learned many years ago. If you add 1 to all the exponents of the prime factorization and take that value, 2 times 3 is 6, times 4 is 24, and that is the answer to problem number 9. Okay? No matter what it is, that little trick works. It's kind of cool. All right. Number 10. This was a Pythagorean theorem problem. It said Claire got on her bike and rode 4 miles due east, so she goes 4, okay? And then she stopped and she rode 3 miles due south, 3. And then she stopped again and rode 7 miles due north, all right? 7, so 3 to that, I'm gonna make sure I have this right. On our bike rode 4 miles due east, 3 miles due south, stopped again. Oh, see, I knew I missed one. I knew I missed one in there. 3 miles due south, my bad. The third leg of her trip was 5 miles due east, 5 miles due east, and stopped again and rode 7 miles due north, okay, and stopped again and rode 6 miles due east, okay, that's east, all right, and she stopped one more time and rode 4 miles due north. Okay, all you got to really figure out is how long that line is, okay? Well, she started here. She went south 3, but she went north 7 and 4. So she actually went up. 7 and 4 is 11, but 3 down. She went up 8, okay, from where she started. And her eastern voyage, she went 4 east, 5 east, that's 9 east, and 6 more east, so she went 15 east, right, from her starting point. From her starting point, she went a total of 8 north, total of 15 east. How far is it from here to here? It's good to memorize your special right triangle triples. 8, 15, 17. This is 17, but if you forgot, you can use the Pythagorean theorem. A squared, a leg squared, plus a leg squared equals hypotenuse squared. 64 and 225 is 289 equals something squared. What squared is 289? 17. All right? 17 is your answer. All right, cool. And number 11. How many diagonals does a dodecagon have? Again, this is one of those things, if you do math contests, like mine, okay, later we're going to have like Kahoots and things like that. You want to be able to do these things quickly. It says, how many diagonals does a dodecagon or a 12-sided figure have? This is number 11, right? So if you think about it, what is a diagonal? It is the distance, or is not a distance, but a line that connects one corner of a polygon to another, but is not a side, right? So like a square or rectangle will have 2 diagonals. A triangle has no diagonals. A 3-sided figure has none because they're all sides. So a 4-sided figure has 2. A 5-sided figure, really fast, I'll draw one of those. If you start here, we got 1, 2, and then we go to here, 3, 4, and then we go to here, this one's already drawn, so 5, and we go to here, these two are already drawn, so 5-sided figure has 5. You may or may not be able to pick up the pattern, but up by 2, up by 3, so a 6-sided figure has plus 4, which is 10. These are called, by the way, triangular numbers. You'll find them on Pascal's triangle. So many cool things you can do. Anyway, so a 7-sided figure will be 15, and an 8-sided figure will be 21, and you could just keep going, right? Because we're adding 6. Now we add 7 for a 9-sided figure, so that'd be 28. Now we add 8 for a 10-sided figure, so that'd be 36. Now we add 9 for an 11-sided figure, and that'd be 45. And then we add 10 for a 12-sided figure, which would be 55. Uh-oh. What did I do wrong? I think I did something wrong. I don't have that down as my answer. Add 5. Oh! Duh. Wow. This is really bad. Sorry, guys. My bad. Again, I'm not remaking the whole video. So add 3, add 4, that's 9. Add 5, that's 14. Add 5, add 6, that's 20. Add 7, that's 27. Add 8, that's 35. Add 9, that's 44. And add 10, that's 54. Sorry about that, guys. All right, but you get the idea. And now there is a special formula for that. It's n times n minus 3 over 2. The number of sides times the number of sides minus 3 divided by 2. So it's 12 times 9 divided by 2. And I could cancel the 12 and the 2. That'd be 6 times 9, 54. Definitely not remaking the video. All right, number 12. It says a rectangular field is 30 meters long and 20 meters wide. All right. This is number 12. Let me erase number 11. Sorry, going fast here. Like I said, you can fast forward me erasing the board times. So number 12, a rectangular field is 30 meters long and 20 meters wide. If the area of the field were doubled by adding the same number of meters to both the length and the width, what would be the length in meters of the new field? So this is number 12. All right, number 12. So it's 30. We'll call this length 30 by 20, okay? And so if the area of the field were doubled by adding the same number of meters to both the length and the width of the field, what would be the length? Well, the area of this is currently 600. So the area of the new field is going to be, it says it's going to be doubled, so it's going to be 1,200. And we have to add the same amount to both the length and the width. All right, now, again, we can do this with formulas and stuff like that, but I'm kind of noticing right away, it's almost like, man, I gotta fix this, but it's almost like really easy to see. 1,200 is gonna be 30 times 40, right? So think about it. If we had 10 there, 30, and we had 10 there, 40, we got it. So it's adding 10, and it says, what's the new length of the field? 40. Okay, so sometimes it is good to just see things and kind of like guess and check. Again, there is a way to do it, like where you can plug in variables and things like that. And if you need help with that, just let me know. All right, number 13. 7 consecutive integers have a sum of 273. What is the largest of the integers? So number 13, 7 consecutive integers have a sum of 243. Now, here's, I think, the easiest way to do this. They're consecutive, so they're all off by 1, right? So if you add them all, and they're close to each other, So if they have a sum of 273, what I just did is I said, you know what? I'm going to take 273 divided by 7, and I'm just going to see how, because if they were all the same, then it would be 273 divided by 7, and then that would be 3, that's 21, that's 6, bring down to 3, 39, right? 39. Okay. So if they were all 39s, then they would add up to 273. So what if we go 39 in the middle, 38, 37, 36, so we're less by 3, by 2, by 1, and we go more by 1, by 2, by 2, so 41, and by 3, 42. Okay? So we kind of got to the middle by just dividing, and then we said, all right, if they're in a row, we'll put 3 on this side, 3 on that side, the middle numbers. And what it's asking, though, is what is the largest of those numbers? That's 42. And question number 14, the sides of a rectangle are in a ratio of 4 to 3. The area of the rectangle is 48. How many centimeters are in the perimeter? Okay. So it's a rectangle in the ratio of 4 to 3. So it's a terrible rectangle, but we'll say 4 and 3. Okay. And the area is 48. So if you think about it, one thing that we could do is we could say, all right, it's in a ratio of 4 to 3, so it's going to be like 6 to 8, 9 to 12. We could use a little algebra here. We could do 3x and 4x. And 3x times 4x is 12x squared equals 48. Okay, because it says the area is 48. We divide by 12 and x squared equals 4. Well, obviously x is 2. Okay? So that means this side is 6 and this side is 8. And now it's asking, what's the perimeter of the rectangle? 6 plus 8 is 14, plus 6 plus 8 again is another 14. So 28. This is problem number 14. Okay? And 28. And again, that one could have been guessed and checked really easily. And then the last one is a crazy picture. It is a rectangle. This is number 15. Let me see, I'm going to try to do this, try to do it fast. If you looked at the grid, you would see that this is 12 inches tall and 10 inches wide, and it even says it on there. And we're looking, and this goes from here to here, but if you count the units, like on the little grid, this is 5, okay? And this is 5, this is 5, right? It's like this is 5. So anyway, it asks, it shades this 5 right here, okay? This whole thing is 12, okay? It says, what is the area of the unshaded region? All right, well, that's pretty easy. So it's basically a rectangle that is 12 by 10, so that's 120. But then we have to subtract the shaded region. Well, the shaded region is 5 by 5, okay, which is 25, but it's a triangle. Remember, when you find the area of a triangle, you have to divide by 2. So 5 times 5 is 25, divided by 2 is 12.5, and then you just subtract and you get 107.5 is your final area of the unshaded region. All right, I know I went super fast. Have a great week. Look for it. I hope if anybody watched all the way to the end, I'm going to tell you a number, all right? Because you watched all the way to the end, and the number is 42, all right? And that might be a bonus for you for this week. All right, have a good day.